Maxima and minima, part 6. A point on the hypotenuse of a right angle triangle is at distance A and B from the sides of the triangle. Show that the minimum length of the hypotenuse is A power 2 by 3 plus B power 2 by 3 whole power 3 by 2. Here, triangle BOA is a right angle at O. We have to find out the length of hypotenuse AB, and we are given that this distance MP is A and NP is B. Here from statement it is clear that a point on the hypotenuse, so P is the point of a right angle triangle, is at distance A. So from here this point is at distance A, and from here this distance is B. Then we have to show that the minimum length of the hypotenuse is A power 2 by 3 plus B power 2 by 3 whole power 3 by 2. So we can write that length of hypotenuse is equal to L will be equal to BP plus AP. So BP will be from here, this is base, this is hypotenuse. So we have to find out hypotenuse. So we can say BP, so B upon BP will be equal to base upon hypotenuse equal to cos theta, from where we get BP equal to B sec theta. Similarly, AP, so this is perpendicular, so we can say A upon AP, perpendicular upon hypotenuse, equal to sine theta, from where we get AP equal to A cosec theta. So we have got the values of BP and AP. Hence, L will be equal to D sec theta plus A cosec theta. Now, we have to differentiate it with respect to theta. So, dl by d theta will be equal to B sec theta tan theta minus A cosec theta into cot theta. Now we find second derivative also. So d to L by d theta 2. So it is better to write on next page. So d to L by d theta 2. So it will become A cosec cube theta plus A cosec theta times cot square theta plus B sec cube theta plus B sec theta into tan square theta. Let's see how. Here, product rule is to be applied. In these two cases, we first write derivative of cosec theta. So here order is reverse, so don't get confused. So either we can write separately. Here B times sec theta will be differentiated and tan theta will be kept intact. Sec theta will give sec theta times tan theta, and then sec theta will be kept intact and tan theta will be differentiated, and that will give sec square theta. Then here, assuming cosec theta first and cot theta second, then we differentiate cosec theta, that gives minus cosec theta cot theta times cot theta, and then we keep cosec theta intact and we differentiate cot theta, that will give minus cosec square theta. So we will get A cosec cube theta plus A cosec theta cot square theta plus B sec cube theta plus b sec theta into tan square theta. Now, for maxima or minima, or for maximum value of L, dl upon d theta must be 0. So we can say here dl upon d theta is this much, a sec theta dot tan theta minus a cos sec theta dot cot theta. So we put it equal to 0. So minus a cos sec theta times cot theta plus b sec theta times tan theta equal to 0. So we simplify it. So a cosec theta times cot theta will be equal to b sec theta into tan theta. We further simplify. So a upon sine theta into cos theta upon sine theta will be b upon cos theta times sine theta upon cos theta. So this will give a upon b equal to sine cube theta divided by cos cube theta. That is tan cube theta equal to a upon b, or tan theta will be equal to a upon b both power 1 by 3, or a power 1 by 3 divided by b power 1 by 3. From here, we can use a right angle triangle. So we have got tan theta as a power 1 by 3 divided by b power 1 by 3. If we draw a triangle, sorry, so this is theta. Tan theta means perpendicular, and this is base b power 1 by 3. And this will be a power 2 by 3 plus b power 2 by 3 using Pythagoras theorem. This is right angle triangle. So from here we can get value of cosec theta as hypotenuse upon perpendicular, that is the root of a power 2 by 3 plus b power 2 by 3 whole divided by a power 1 by 3, and sec theta as hypotenuse upon base, that is a power 2 by 3 plus b power 2 by 3 divided by b power 1 by 3. Now we are going to put these values in expression of second derivative d2l by d theta 2. That was a cosec cube theta plus a cosec theta times cot square theta plus b sec cube theta plus b sec theta tan square theta. Since all values are positive, so obviously d2l by d theta 2 will be greater than 0. Hence, function will be minimum. So, function is minimum. Now, we have to find out length of hypotenuse. So, let's see what is length of hypotenuse. So, as we have already written, L equal to A cosec theta plus B sec theta. We put the values. So L equal to, I'm changing the color so that it may not get mixed. So L equal to A times cosec theta. Cosec theta is this much. A power 2 by 3 plus B power 2 by 3 under root divided by A power 1 by 3 plus B times sec theta. And sec theta is this much. root of a power 2 by 3 plus b power 2 by 3 whole divided by b power 1 by 3. Now we simplify it. So on simplification, we get L equal to here a power 1 divided by a power 1/3. So power rule a power m divided by a power n is a power m minus n. So here 1 minus 1 by 3, that will give 2 by 3. So we can say a power 2 by 3 times here this term is common. So what we can do, we can take common root of a power 2 by 3 plus b power 2 by 3, and then we write here a power 2 by 3. Similarly, b power 1 divided by b power 1/3 will become b power 2/3 whole divided by a power 1/3 into b power 1/3. So what do we get? Now this is power half, and so here I've written it wrongly, because when a power 1 divided by a power 1/3 is simplified, we get a power 2/3 plus here b power 1 divided by b power 1/3 will become b power 2/3. So we can write them together, because we know that x power 1 into x power half gives x power 3 by 2. So here L will be a power 2 by 3 plus b power 2 by 3 whole power. Here power is 1 and here power is half. So this will become 3 by 2. So this is length of the hypotenuse. Now let's go back to the question. Here question was the minimum length of the hypotenuse is a power 2/3 plus b power 2/3 whole power 3 by 2. And our result is here L equal to a power 2/3 plus b power 2/3 whole power 3 by 2. Thank you for watching.